Hello everyone, today in this video we'll be discussing the first semester Max BMATS101 M1 super important questions from the exam point of view. I've taken these papers, I've taken these questions from the previous papers as well as the model question papers from the 18 scheme, 21 scheme and 22 scheme. So all these topics which are discussed here are the most important and the repeated ones, and if you want more of these topics, I have the all the list of set of super repeated topics. You can DM me on Instagram. I'll be sending it to you. And before starting, please do like and subscribe. It helps me make more videos like this, and this video is sufficient for you to score more than 80% marks. All these topics, if you discuss if you understand as I explain you, you'll be easily able to score more than 80% marks. Okay, so these are the most repeated topics. So without wasting more time, let's get started with the first topic, which is important proofs. Okay, so there are some important proofs which have repeated in almost all the previous year papers. Okay, so the first one is, with usual notation, prove that tan phi is equal to r d theta by dr. Okay, so this question usually comes in the 1a part. Okay, in the first part of the or question. So here this is the diagram you need to make. Okay, all you have to do is you have to make an angle theta here and draw a line like this. Okay, after you have done that, mark this point as o. Okay, this is the starting point 0 0, and this angle will be known as theta. Okay, and you will be drawing one another line here which will be the x-axis at this point, and this angle will be psi. Okay, this angle will be psi, and the phi angle will be made between this line and this line. Okay, and the point which is present here is p, which is called r comma theta. Okay, and there will be a curve passing through this point which will be called r is equal to f theta. So we have to prove tan phi is equal to r d theta by dr. The first step what you need to write is psi is equal to phi plus theta. Okay, this angle is nothing but the sum of the interior angles. Okay, this is the property of triangle. The exterior angle is equal to the sum of opposite interior angles. So we'll be writing these two things. Okay, after that we know tan psi is equal to tan phi plus theta. So we'll be taking tan on both the sides, and tan a plus b is nothing but tan a plus tan b divided by 1 minus tan a tan b. Okay, this is the one equation we'll be marking it. Okay, also we know that m is the slope is nothing but tan psi is equal to dy by dx. Okay, slope is nothing but dy by dx. So tan psi is equal to dy by dx, and let r cos theta is equal to x and r sin theta is equal to y. Okay, easy. We'll take x as what, r cos theta, and we'll take y as what, r sin theta. Always y axis will be associated with sin theta, and x axis will be associated with the cos theta. Okay, we'll be differentiating both of them with respect to theta. Okay, so when we differentiate this with respect to theta, we'll be getting this part here, and when we differentiate x with respect to theta, we'll get this here. Okay, similar thing we'll do with y also. Okay, when we do it with y, we'll be getting dy by d theta is equal to sin theta dr by d theta plus r cos theta. Okay, now from the equation 2 we know that tan psi is equal to dy by dx, right? So dy by dx, both I am dividing it by d theta. Okay, so that we get dy by d theta and dx by d theta. Okay, you got the point. What was tan psi from the equation 2? If we revisit the equation 2, tan psi was equal to dy by dx. I'm just dividing it by d theta here, and here also I'm dividing by d theta. Okay, so I'll be getting dy by d theta and dx by d theta. Now dy by d theta also I have, dx by d theta also I have. Okay, this is the dx by d theta. Okay, both of these I'll be substituting it here. Okay, after I've substituted it here, I'll be dividing the numerator as well as the denominator by cos theta dr by d theta. Okay, cos theta dr by d theta will be divided in the numerator as well as in the denominator. Okay, both the part it will be divided. Okay, this is the step you need to follow for simplification. After that, dr by d theta will get cancelled from here. This will become tan theta, and this cos theta will get cancelled from here, and from here cos theta and both of these will get cancelled, and from here sin theta by cos theta will become tan theta. So basically the simplified equation will be looking like this: tan theta plus r d theta by dr, 1 minus tan theta r d theta by dr. Okay, now tan psi, we already know what is tan psi. Tan psi is nothing but tan theta plus phi, right? What is tan theta plus phi? We had expanded it for at the top, right? This is the equation, right? This is tan psi. Tan psi is equal to this. So this one I'll be substituting. Okay, so when we substitute this one here, we'll be able to see this one is equal to this one. Okay, we are just substituted this part here. Okay, this part remains same here. We are just substituted this for this. Now if we compare, tan theta is equal to tan theta, good, and this angle is equal to this whole thing. Sorry, not angle, tan phi is equal to this whole thing. Okay, this is one observation I will be making it here. And another observation, tan phi is equal to this. So if tan phi is equal to this, if we do the upside down of it, so tan phi's upside down will be 1 by tan phi, which is nothing but cot phi. Okay, inverse of tan phi is cot phi. If you do the inverse here also, r will become 1 by r, and d theta by dr will become dr by d theta. So this is the equation we needed to prove. Okay, this or this both are same. Okay, we had to prove tan phi is equal to r d theta by dr. Okay, practice this 3 or 4 times. This is the most repeated question from the M1. Okay, don't miss this one. Moving on to the second super important proof, we have with usual notation proof that 1 by p square is equal to 1 by r square plus 1 by r4 dr by d theta square. Okay, again very simple. You just have to make one diagram here. Starting point you will take as O. Okay, O, what you will mark it as 0 0. Okay, and again there will be a curve passing from here, and this angle will be called as theta, and this angle will be called as phi. And instead of this angle as we did previously, we will be extending this line till this point, and this point will be called as t here. Okay, this is the tangent. Okay, and this point is called as m. Okay, and p will be as usual here only, and p is the point here. Okay, this is the capital P, this is the small p. Small p is denoting the line OM. Okay, p is equal to OM. Okay, this is the line. Okay, this whole line is denoted by p, and this angle is pi by 2. Even if in the diagram it doesn't look pi by 2, this we'll be assuming it as pi by 2. Okay, so from the angle from the triangle OPM you have to start. Which triangle you will start? OPM. Okay, so this is looking like pi by 2, but it doesn't matter. Okay, all matters is what proof you write. You'll be getting marks based on the proof, not on the diagram. Okay, so this is 90 degree. Now what is sine phi? Sine phi is nothing but opposite side by hypotenuse. Opposite side is this one P, hypotenuse is this one. This is the hypotenuse. Why is this hypotenuse? What is hypotenuse? Hypotenuse in a right angle triangle is the side which is opposite to the 90 degree. So opposite to 90 degree is this here, even if it does not look intuitively because of this type of diagram, but this is the hypotenuse. So sine phi will be nothing but opposite side by hypotenuse, P by R. Okay, P by R. So what we will get? P is equal to R sine phi. Good. Now we'll square both the sides and take the inverse of it, and we'll take 1 by sine square as cos sec square, and cot sec square is nothing but 1 plus cot square. Okay, now tan phi we know r d theta by dr from the previous proof, so cot phi will be 1 by r dr by d theta. Okay, so cot phi, here it is cot square phi, will be substituting cot phi in this place. Okay, when you substitute that and take the square, we will be arriving at this equation which we needed to prove. Okay, moving on to the third super important proof, we have with usual notations proved that p is equal to 1 plus y1 square raised to 3 by 2 divided by y2. Okay, y1 is the first differentiation and y2 is the second differentiation. For this you have to make this simple diagram. You just make a single line here and you will make a curve here. Okay, and this point is the tangent, and m is the slope which is tan psi, and f of xy is equal to c. Okay, after that m is equal to tan psi is equal to y1. y1 is nothing but dy by dx. What is slope? Slope is dy by dx, the rate of change of y with respect to x, right? So dy by dx can be denoted as y1 here. Okay, now if you take psi here and take tan into the other side, we'll get psi is equal to tan inverse of y1. Now differentiate both with respect to theta. D psi by d theta is equal to tan inverse of y1. The differentiation of tan y is equal to, see, differentiation of tan inverse of y. Differentiation of tan inverse of y is nothing but 1 by 1 plus y into dy by dx. Okay, so you need to look at that table where the differentiation is given. So it will be 1 by y1 square. It is not just y1, it is y1 square. We will take it in the bottom, and dy y1 by dx, because y1 with respect to theta we are differentiating. Actually this is supposed to be theta. Okay, this is supposed to be theta. Okay, after that d psi by d theta, what we will be getting is y2. This whole thing can be taken as y2 and divided by 1 plus y1 square. Okay, y2 divided by 1 plus y1 square. Now ds by dx is equal to 1 plus y1 square root. You have to write this one. Okay, this is a known formula. ds by dx is equal to root of 1 plus y1 square. Okay, till here you got the point, right? What we did, we will take first tan psi and take the inverse and do the differentiation. After that we'll be getting an equation here and we'll be writing it here. Okay, after that we have to take this formula. P is equal to ds by d psi. Okay, this is also a known formula. P is equal to ds by d psi. After that, we'll be dividing both the parts by x here. Okay, ds by dx will be doing, and d psi by dx will be doing. Okay, so when we do that, ds by dx, what is ds by dx? Ds by dx is nothing but 1 plus y1 square. Okay, so we'll be substituting 1 plus y1 square in the numerator, and d psi by dx, d psi by dx is nothing but we have got this. Okay, actually this is not with respect to theta. Let me make that change. It is respect to x only. Okay. Okay, this is with respect to x we are differentiating, so it will be dx here, and this will also be dx here. Okay, that was the confusion, so it is clear. Okay, now we are just substituting this part here, d psi by dx and ds by dx in the numerator and denominator. When we substitute that, we'll be getting this equation here. As you can see, this is the root of this. Okay, means if we square this, we'll be getting this. Right, so we can cancel these both. Okay, and the denominator will be, sorry, we cannot cancel it because this is already in the denominator. When we switch it to the top, it will come it like this, 1 plus y1 square. Okay, like this it will come. This is a root and this will be here, right? This is how the fraction works. See, a by a, b by c, what this will become, ac by b, right? These both are equivalent. So we'll be getting this one, and we can add up 1 and 1 by 2 and 1, because these two bases are same. So 1 plus 2, 1 by 2 plus 1 is 3 by 2, so 3 by 2 will be getting here, and 1 plus y1 square will remain as such, and y2 will also remain as such. This is the proof we needed to do, right? You can write this 2 or 3 times, and don't, make sure you don't miss this question. This is a super repeated one. Okay, moving on to the second topic, which is finding the angle between two curves. Okay, one technique is there. Okay, you just need to remember the steps, and if you remember the steps easily, you can solve any question. Okay, given that you know about the differentiations of each of these trigonometric functions. Okay, and the log values functions also you need to know, because you will be taking log very frequently in finding the angle. Okay, now the step one, what you have to do, you'll be given in the question in the examination, find the angle between the curves. One curve will be given here, and separated by a comma another curve will be given. Okay, two curves will be given to us. So divide the page into two parts. Okay, and write the first curve here and the second curve here. After that, you have to take log on both the sides. No matter what the question is, you always have to take log on both the sides. R is equal to a log theta. Take log on both the sides. So this will become log r, and this will become log a plus log theta. Why I have taken plus here? Because that's the rule. If you take a into b, log of a into b, that is equivalent to log a plus log b. Okay, this is the logarithmetic formula. So log a, this will be separated here, plus log of log theta. Okay, differentiate with respect to theta both the sides, this part also and this part also. When we differentiate with respect to theta, we will be getting log r. See, differentiation of log, what is differentiation of log x? 1 by x, right? So since it is r here, it will become 1 by r. And since we are differentiating with respect to theta, and we have r here in the variable, so we will be writing dr by d theta also. Okay, same he will do here also. Log a is constant, so constants differentiation is 0. And here what we will do, log of log theta is there, right? So what is a differentiation of log theta? 1 by log theta, and into differentiation of log theta, which is 1 by theta, into differentiation of theta, which is d theta by d theta, that is equal to 1. So this will be the expanded form here. Now this answer we know, 1 by r dr by d theta is cot phi. We'll be writing it as such here, and this answer will be 1 by theta log theta. Now tan phi is nothing but theta log theta. We have got, we will be inversing this. Inverse of cot phi is tan phi, and inverse of this is theta log theta. Now we have got this, and we'll be keeping it as such. Next, we'll be doing the same things in this side also, except that here division is there. So log a by b is log a minus log b. Listen to me again. Log a by b is equal to log a minus log b. Okay, log a minus log b. So we'll be writing log a minus log b, differentiating in respect to theta, and we'll be getting an answer here. Tan phi 2 we'll be getting. The first step is take log on both the sides and find out the tan phi 1 and tan phi 2. After you have done that, you'll be applying this formula. Tan phi 1 minus phi 2 is equal to tan phi 1 minus tan phi 2 divided by 1 plus tan phi 1 into tan phi 2. Tan phi 1 and tan phi 2 values we have, will be substituting in all of these places, and then simplifying it. Okay, after we simplify, we will be obtaining at an equation similar to this one. Okay, so in this question, this is the equation which we will be approaching. Okay, in other questions, a similar equation will be coming. After that, your third step. Okay, second step was what? Take this formula. Third step is to find theta will be substituting r is equal to a log theta and r is equal to a by log theta. Now since r is equal to a log theta and r is equal to a by log theta, equate both of these and find out the value of theta. We'll get log theta whole square is equal to 1, log theta is equal to 1, and this is the log base e. Okay, log base e, and theta is also present here, is equal to 1. What is theta in case of log theta is equal to 1? The theta value should be equal to the base for it to get 1. Okay, this is the logarithmetic basics. Okay, when it is base and the variable is same here, then only we'll get as 1. So the value of theta will get as e. Okay, now we'll substitute wherever we find theta as e, and log e value is equal to 1. Okay, log e value is equal to 1, logarithmic value of e is 1. Wherever log e is present, we'll be putting it as 1. So the angle between the two curves phi1 and phi2, will be getting it as tan inverse of 2e by 1 minus e square. Okay, this is the final answer we will be writing. Okay, angle between two curves. For all the questions, you need to follow these three steps. Okay, a similar type of topic is there, which is also here. Also we'll find out the angle between two curves, but in a slightly different manner. Okay, show that the two curves cut each other orthogonally. Very important question, don't miss this at any cost. Okay, show that the curves r is equal to a 1 plus sin theta, r is equal to a 1 minus sin theta. Two curves are given to us, and we have to find out that they cut each other orthogonally. Orthogonally means what? At 90 degree. Okay, this is the curve 1 and this is the curve 2. In between, the angle when they intersect will be 90 degree. Okay, that we have to prove. Okay, and this value will change. Okay, this value they can give as 1 plus cos theta, 1 minus cos theta, 1 by sec theta, or any other values will give. You don't have to care about what values they give. You just have to follow the same steps. First step, divided into two parts here. The first part you will be writing the formula here. Okay, the formula is written. After that, you will be taking log on both the sides. So log r will be equal to log a plus log 1 plus sin theta. Here also log a log 1 minus sin theta. Differentiate with respect to theta on both the sides. You will be obtaining an equation cot phi, and in this case keep it as cot phi only. Your step 2 is to multiply 1 and 2. This answer we got and this answer we got. What we will be doing, we will be multiplying both of them. When we multiply both of them and simplify, we will be getting minus 1. When we get minus 1 on the multiplication of cot phi 1 and cot phi 2, that is an indication that they are 90 degree. Okay, orthogonal. So these two curves cut each other at 90 degree. Again, the first two things you need to do, write these two things here and then take log on both the sides, multiply the cot values of each of them, and if you get minus 1, both the curves cut each other at 90 degree or orthogonally. Okay, moving on to the next super important topic, which is find the radius of curvature. Okay, radius of curvature, many questions can come, and in this type there can be polar form, there can be Cartesian form, and there can be parametric form. Okay, parametric, but polar and Cartesian are the most repeated ones, so I'll be discussing those two. Okay, if you want the questions related to the parametric form from the previous papers also, you can DM me on Insta, I'll be sending you. Okay, find the radius of curvature of the curve y is equal to x cube x minus a at the point a comma 0. Okay, the first step what you need to do, find out the radius of curvature for this. Okay, and the point also they have given. So while finding out the radius, we'll be substituting the point as well. Okay, I'll repeat, while finding out the radius, we'll be substituting the point as well. Okay, let's have a look. So the first step, just write the same formula here which is given to you, and after that expand this. X cube into x is x power 4 and x cube into a is ax cube. Differentiate with respect to x both the sides, so this will become y1 and this will become 4x cube, and ax cube's differentiation is 3ax square. We have got the value of y1. Now they have given the point a comma 0, right? This is the point which they have given, a comma 0. A is x value and 0 is y value. So we have to substitute the x value as a. Wherever you find x here, say substitute it as a. When you substitute it as a, we'll get 4a cube minus 3a cube, which is nothing but a cube. So y1's value will become a cube. Okay, y1's value will become a cube. Now again differentiate y1 with respect to x. We have to find y2. Okay, y1's differentiation is y2. Okay, so y2 will become differentiation of this one. So this will become 12x square, and this will become 6ax. Okay, again substitute the value of x as a here, and we'll get y2 value also. We have y1 value, we have y2 value. The radius of curvature formula is this one, we just derived in the previous question. So we'll substitute y1 as a cube and y2 as 6a square. When you do that and simplify, we'll get the radius of curvature. Okay, so for all these questions you have to do the same thing. Let's again see what's the formula. First you have to take the formula, expand it and differentiate with respect to x to find y1, substitute ay and substitute the value which they have given, a comma 0, find out the y1 value. Again find out y2 by differentiating this y1. Okay, you should not differentiate this y1, you should differentiate this y1. You'll get a y2 value, and substitute y2 value also as a comma 0, you'll get y2 value. Substitute both of these values in this equation. This is the important equation, you have to remember this one. Okay, after substituting you will be getting a radius of curvature answer. This is the final answer which you'll be getting. Okay, for all uh, Cartesian form, you have to do this one. Okay, Cartesian form means it will not have theta values. Okay, this question does not have theta values. If you observe carefully, there is no theta values present here, only x and y. Okay, if there is theta value and r value present, that is called as polar form. They can ask you the radius of curvature in the polar form as well. So separate formula is there. Okay, so you just have to take the same thing here, r power n, a power n, sin n theta. Take log on both the sides. When you take log on both the sides, you'll be getting log rn, log a power n, sin n theta. Right? Okay, after that expand this formula, log x power y. What is log x power y? Log x power y is nothing but y log x. Okay, log x power y is nothing but y log x. So like that, n log r will write here, and this one we will be expanding, and we'll be getting n log a here and log sin n theta. After that we'll be differentiating with respect to theta. Okay, when we differentiate with respect to theta for both of these, we'll be getting n into 1 by r into dr by d theta is equal to, this one will become 0, and this will become 1 by sin n theta into the differentiation of sin n theta is cos n theta into n. Okay, after that we'll be taking dr by d theta as r1. Okay, what will we take? Dr by d theta as r1, and what we'll be getting here, if we take this value as r1, this will be r1 by 1. Okay, r1 by r1 by r is equal to cos n theta by sin n theta. Okay, this is cos n theta, this is sin n theta. Okay, and what is cos by sin? It is cot. Okay, so r1 value will get r cot n theta. Okay, when you shift r to here, we will be getting r1 is equal to r cot n theta. After that we'll be differentiating with respect to theta. Okay, so again from the starting what we did, first we took this formula, take log on both the sides, differentiate with respect to theta, and write it in the form of r1. Okay, after that second step is to find r2, right? So we'll differentiate r1 with respect to theta, so r2 value this will be getting. Okay, and this one will be just simplifying it, and we'll be writing the formula. Okay, like previously how we wrote the formula, 1 plus y1 square power 3 by 2 divided by y2. Here the formula is r square plus r1 square raised to 3 by 2 divided by r square plus 2r1 square minus rr2. Now we have the value of r2 from the 3, and we have the value of r1 from 2. We'll substitute both of them. Okay, you can go through it slowly, and when you substitute them and simplify it, you'll be obtaining an equation here. Finally, the equation which we'll be getting is 1 by n plus 1 r cosec n theta. Okay, this is the fourth equation. Now this is not the final answer, we have to eliminate theta. Okay, before that there are some things which I need to tell you. See here, we'll be getting a common thing here, r square and r square here. Okay, we'll take r square as common, so what we'll get, 1 plus cot n theta square. What is 1 plus cot square theta? It is cosec square theta, so we'll write cosec square theta here. Also here we have cosec square theta, so we'll take cosec square theta as common, r square cosec square theta, you'll get 1 plus n. Okay, and here cosec cube n theta is there and square is there, it will get cancelled. So if you go through the steps very carefully, you'll be able to know how the simplification is done. Okay, to keep the video simple, I'm not going through these steps. Okay, so after that to eliminate theta, what we can do, from the first equation which they had given, okay, you have to consider that. Okay, second step is arrive at this equation after simplification. The third step is r power n, a power n, sin n theta. This is the equation they had given, right? So sin n theta is present here and cosec n theta is present here. What is cosec? 1 by sin, right? So sin theta is present here, we will take 1 by sin theta. 1 by sin theta is nothing but a power n by r power n. We just took sin theta here and r theta here, so r power n here, so a power n by r power n is equal to this one, and this is nothing but cosec n theta. Cosec n theta we got a power n by r power n. This is the compulsory steps. At the last we have to substitute the value of cosec n theta, so a power n, r power n will substitute it here, so we'll be obtaining this equation, and on further simplification we'll be obtaining the final answer here. Okay, this is the thing you need to do for the values where they give the theta. Okay, the polar form radius of curvature. Okay, Moving on to the last super important topic, which is find the pedal equation of the curve. Okay, this is also a very super repeated concept. Don't miss this one. Finding the pedal equation is pretty simple. They have given you a curve here. Okay, 2a by r is equal to 1 plus cos theta. Okay, so we'll be writing this here, taking log on both the sides. Wherever the question is related to theta, the first step will be to take log on both the sides. I'll repeat, wherever the question is with respect to theta, you have to take log on both the sides. Take the log on both the sides and differentiate with respect to theta. So we'll be getting minus 1 by r dr by d theta, that is nothing but cot phi, and here this answer will be sin theta by 1 plus cos theta. The pedal equation we have derived, that is equal to 1 by p square 1 by r square into 1 plus cot phi. Okay, this equation will be substituting cot phi value. When you substitute that here and we'll be expanding it, again we'll be simplifying it, we'll be keeping denominator as same here, and the numerator will be simplifying. Cos square theta plus sin square theta is 1, so 1 plus 1 is 2, 2 plus 2 cos theta. What is 2 plus 2 cos theta? We'll take 2 as common and it will become 1 plus cos theta. Okay, so this will be written here, and the 1 plus cos theta will be cancelled from the denominator square, so it will become 2 by 1 plus cos theta. Okay, this is the final answer you'll get. Don't miss any of this question. This is super important ones, and please do like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.